Hello, I'm Wenke Huang. In this talk, I will introduce our paper, Learn from Others and Be Yourself in Heterogeneous Federated Learning. Deep learning has made remarkable progresses owing to the availability of large-scale data. However, in the real world, data are commonly dispersed. Due to growing privacy, we cannot integrate data together to train models. Driven by such a problem, federated learning provides a price-preserving solution. Along with its pilot progresses, a practical challenge is the heterogeneity problem. On the one hand, distributed data might be long-ID distribution, leading to data heterogeneity. In particular, private models suffer performance degradation on other domains with different distribution. Then comes the question, how to learn a generalizable representation in data heterogeneous federated learning. On the other hand, due to different design criteria, distinct hardware capabilities, and intelligent property rights, participation required to customize models, which pose a practical challenge, model heterogeneity. Therefore, how to reach communication in model heterogeneous federated learning. Besides the heterogeneity problem, another impediment for federated learning stems from its paradigm. When there is a domain shift between private data, the model optimizes on the local data and forgets the previous knowledge, resulting in catastrophic forgetting. Therefore, how to balance this multiple knowledge to reduce catastrophic forgetting. Specifically, we leverage unlabeled public data and logic output to reach heterogeneous models communication, and further require logic output environment to domain distortion, and decorrelating different dimensions of logic output on unlabeled public data. Considering the communication cost, we get the advanced logic output. The loss function is as follows. In local updating, current methods suffer catastrophic forgetting mainly due to the following two limitations. In local updating, without supervision from others' participation, models easily overfit the local data distribution and present poor inter-domain performance. Besides, it only penalizes the prediction independently with paired probabilities, which provides limited and hard intra-information. Therefore, we developed a federated continuous learning method to address its two problems through regularizing the objective from model-rich aspects. Specifically, we leverage previously learned model from previously communication epoch to provide inter-domain knowledge. Besides, we utilize the pre-trained model to provide soft and rich intra-domain information. Our method boosts both the inter- and intra-domain performance. We conduct experiments on digits and office home seniors. As for models, we selected ResNet 10, 12, ShuffleNet, and MobileNet for different participations. We further use intra-accuracies and inter-accuracies to evaluate different methods. We first compare the inter-domain performance with other counterparts. We then compare the intra-domain performance with others. That's all. Thanks for your listening.